1K lines of code based on the scraped product data that was looked up at Amazon. Pretty neat price comparison, eh? Well, you will be definitely able to do something better or equal based on the knowledge that you will receive from watching this video. But without a doubt, you'll be able to do something even better. Stay tuned and enjoy. Good day, ladies and gentlemen. Business engineer here, back with some more scraping projects. So, today we're gonna be looking at something interesting, and it's definitely gonna be hairy, since we're gonna be parsing data from this e-commerce website. And of course, passing the data to Amazon and comparing the prices. So, let's get this hairy thing out of the way. I've created the code. All I'm gonna do is just go over it. So, let's begin. So we have our basic imports. We have our crawl spider, form request, then an ordinary request. This is the item from our item pipeline, which is this one. And this is a function that I've created. We're gonna go through it later, and a time. So, basic class, we inherit from here, we give it a name, and we give it a starting point. And a class variable, which is a list. So, inside of the init, we have a product type, brand, and screen size. They're set to default values, since that way they aren't necessary to be entered inside of the terminal. But if you leave at least one of them empty, you won't get any output. So our data will be based on the input that we provide. So here we assign it inside of the constructor and call superinit. So that being said, let's jump into settings and get it out of the way. So first, with pip, I installed Scrapy user agent and Scrapy rotating proxies. Let's get this baby bigger, as well as this here. We all want to see correct. So this is basically what I've installed. I won't gonna install it again. Yep, and I won't need this. So, user agents. This setting is based on the user agents that I've installed. Only I gave it my personal user agents. I have a file with different kind of user agents, so I'm using them instead of the default ones. Here we obey the rules when it's necessary and when everyone is looking. Otherwise, that's for you to decide. Yeah, so we enable the middleware that is required by the user agent that we installed and the rotating proxies that we installed. You can Google up the names. You will get a GitHub link with instructions. So download delay of 3. This is a required proxy list pad by the rotating proxies, and we have enabled this so that if for some reason our connection drops, data won't be lost. It will try to get the data from the connection again. So, default request headers. This was a simple copy paste. It had a user agent in it. I uncommented. This wasn't in there. I was testing. So we have our own user agent, and for this you want to mimic a request that was made by a browser. If we can't make a mimic of it, like complete copy, we actually have to be very close to it. So that's why these headers these headers play a big role. The only thing I uncommented this line. I'm getting some weird errors for I don't know what reason. So I set the concurrent request to 2. Since I'm a polite person, I don't want to overload the servers and cause a DDoS for some reason. Enabled cookies false. Uncommented the default pipeline, and that's it basically. Yeah, let's move to code. So here we initialize parse. We give it a 3 lists, 1 for type, 1 for brand, 1 for screen size, and the same 3 empty strings for each value that we provide in our constructor. So this is the starting CSS point for our form. I'm not gonna be going over the hierarchy of the CSS. You can do that on your own. Basically, I'm just gonna be showing you the correct paths to it. Yeah, this is very uncomfortable, but whatever. So this is the base path for the form. So we start with the device type, product type. So first we check if it isn't none. Then we go to this drop down and we iterate through every available option here and extract it. If we find the provided value, then this product type that we assign the found element to it. We split the double quotation marks and take the second element of the array that we were provided. Then we break out of it. So next, if we take a look at actually I'm gonna do it like this. So if you look at the options provided, each of them has a value, and the query that we're gonna do is based on this option value, not the text inside of the value, but the option itself. So what we do here is first we split the value basically here, so that leaves us with basically this option value and the value itself. So we take the first element of it, which will be, for some reason, it should be this. Then we split this value and we're taking the 0 element. This looks funky actually, but it works. So anyway, we append the value to the type list. Next we check if product type is an empty string and self the type is not on. Basically what we do here is if the product type wasn't found, we split all the values. Oh yeah, that's right. We were actually fishing for this value here. I got confused. basically we append all the types to it, and if user did input something that isn't inside of the list, we print all the available options. So, and here, if our item was found, we simply assign it and break out of it. So, same approach for each other one, except the brand. It's slightly different because some elements are camel cased and some are not. For example, there are two Apple products. One is capitalized and one is not. So that's a workaround around it. So let me actually give you a example. I'm just gonna uncomment this here out. I'm actually gonna open a new terminal since I have some example data back there. I'm gonna cd scrapey crawl hunter a brand. Let's give this. So these are all available brand options. Neat, huh? Not bad. Not bad. So moving on. Let's close this, this, and this, and this. Okay, cool. So the URL. Normally we would submit the form request here, but since the URL that it yields isn't working, and we actually need to hard code the URL here. So as you see, I've put some curly braces inside of the type, inside of the brand, and the screen size, and I'm simply formatting the data that was provided, and I simply yield a request. So let's, for example, take Apple. Where's Apple? Oh, they fixed it. There were two Apple products. Okay, so we're looking for Apple and we're basically here. So we give it a starting point, which is basically the unordered list of this everything, and we iterate through it. Let's just inspect. And here you have it, the item class. Oops. So the item class. So we fish for the title, we fish for the price. Some of these have a discount, like this one. In this case, this won't work. So we're doing a basic check. The price is none. We're trying a different path. So here we're looking, if the price is less than 100, we don't want, if the price is higher than 100, then we're appending it to the list. So this list is a temporary buffer. Next we look for pagination. It targets this next arrow here, and it targets the href. So in order to get the href, we give it a tag and the attribute selector and select the href out of it. Then we check if the pagination is not none, we yield a request with the second page. As a callback, we give it the same function, so basically it's a recursive function. Otherwise, if you don't find any pagination, we simply yield an Amazon request. So before we move on, I didn't mention this. That's what we're gonna do now. So I had some output here before, and we're gonna actually look what it does. So this function. So this function takes in an item and the brand that's provided. Let's see what it does. So here I hard-coded some values, which is the year, RAM, SSD, CPU, screen, and Apple products. I'm importing chain from the other tools. So why do we need this? We're basically scraping this data from the title provided so we can assign key value pairs to it. For example, if the title has one of these values in it, we can extract that data from the title and assign it to RAM. That way our search title will be more generic. And same for every else. As for the brand, in case it's an Apple product, we can assign one of this to the title right away. So here, let me check. Yeah, here, this is the item that I printed out that wasn't parsed by this function, and this is the same product that's parsed by this function. So here you see we have a simple one big line title and the price in pounds. So here excuse me, we extract the data. As you see, our title is simple Apple Mac Pro. We have an SSD value. We couldn't find the CPU here, and we have a 32 gigabytes of RAM. Screen size none, year none, and the price is converted to euro. So I can actually copy this and insert it somewhere here. Cool. Now I have one more spec just for the next time. Maybe I can find something more. Yeah, maybe. So here we take the item, we assign the title to the title. Next, we're looping through the SSD through each element, and we're looking if one of these is inside of the title, and we're assigning to it. Same process for everything else. As for the year, we're checking if the element from the list is inside of the year, and we replace these here with an empty string. Next, we check if the pound is inside of the price. If it is, we replace the pound with an empty string, we replace the new line with an empty string, and we replace the comma with an empty string. That way we can make the float out of the price, time it by 1.7, which was the conversion rate from pound to euro, when I looked it up. We make this all a string and we partition it. Basically what this does is select the first element after the dot sign. Basically if this is something like 235 point, I don't know, some decimal values, we're gonna extract only this one. So same for the dollar, only here we convert it to dollars. This will be necessary when we will be looking up the products on Amazon. So if the brand is Apple, we check for the Apple brand, assign the title. If it's not, we split the double quotation marks, take the first element, and we are looping through every list, checking if the title contains any elements of the list. If it does, we replace it with an empty string. So next we return a dictionary. We give a title of zeroed elements since it returns a list. We check if its length is higher than 0. Otherwise, we return the default title. Same for the SSD. If the length is higher than 0, we return it, otherwise an empty string. Same for everything else except price. So that's out of the way. So now we're at Amazon. No, not yet. We're only starting the request. Actually, while we're going through it, I'm gonna start a request in the background. So here we're yielding the callback. Here I'm setting the request to 1, just to see the output, how many requests I'm gonna make. So next we loop through all the products inside of the list. For the title, we assign the title plus SSD if the CPU is empty. Otherwise, we give it a title plus the CPU params plus the year. Next, we yield the form request. This is how you yield the form request. Basically call form request, use form response, and the give current response. You definitely need the form name, either its ID or a form name in our case, which is form name. Let's take a look at it. And our form is here. So the name is site name. So it accepts these kind of query parameters, which is field keywords, and we assign title to it. For the meta, we're giving it the current item that we're looping through. This will be useful. In a moment I'll explain why. We're giving a depth of 10. What this means, it can go like 10 layers below the original one. As a callback is our Amazon search. Here I'm printing out the request number, incrementing the number, and I'm giving sleep for 1 second. Otherwise it will, like in case of a brand like Asus that I tried, actually yielded like 90 requests in 2 seconds, which we don't want to do. So back at Amazon search. Basically, some products aren't found. This is where this comes in place. It searches for the text that's being provided if the product was not found, and it extracts it. Here we're checking if this isn't none, which means it was found. Then we print that the product wasn't found and simply return, since we don't want it to go on. Here we go at the starting point. For example, let me search for iPhone. So our starting point is basically this. Here, this product. Here we're creating our item, which has two variables, main item and secondary item. Both of them are dictionaries. Why, you'll see in a moment. So for the main item, I'm assigning the current item that we're looking through. I'm getting it through response.meta. I'm able to get it since I've added to the meta. And be aware, when you're passing data through like this, the meta isn't sticky. So which means you need to assign it every time you make a new request. In case you will need the data, of course. For example, when we're looking for the pagination on the Amazon, here I'm assigning this item again. Otherwise, if I would yield this request, then this item wouldn't be present. So we assign the main item, and next we're looping through all the products. So this is the path for the title, this is the path for the URL, this is the path for the price. If it wasn't found, we give it none, just to avoid some weird exceptions. And if we couldn't find the price, we don't need the product. So this statement does that. Here we make a sample out of the find item and the price, and we're parsing that item the same way as we did here. No, here. So, and this is where the secondary item comes in, and we're yielding it. So the second item has the same params and the URL, of course, which is the URL to the item. The pagination works the same way. It targets the next arrow. Next, it looks if the pagination was found. Take the last element of the found array, which is the number of the page. Next, we're checking if the page is less or equal to 5, then we're yielding the request. So, again, in a recursive manner. So, that's the main thing. Next, inside of the pipeline, what we're doing here. We're actually putting all the found data inside of a JSON. So, in the constructor, we're creating a variable that's a dictionary, and it has a key of main and a list assigned to it. Next, we initialize the super, and here we're processing through the item that was yielded. We give it a flag, so we are looping through each item in the main. If the item inside of the main and its title is inside of iTitle, this is the item that we yielded, and this is the item that's already inside of the list. So for the item that's inside of the list, it has a lead key, which is a list, and we're appending a secondary item that's inside of this item to that list. Next, we are taking that list, we're sorting it out. So sorted accepts an iterable, which is the list that we're using, and for the key we're using item getter from the operator to sort it by price. Item getter basically works with dictionaries, and it supports multiple key pairs. For example, I can do like title here as well. It will sort by the price and by title. Lambdas can do that. And here we're setting the flag to true and we're breaking. Next, if the flag is false, meaning this wasn't found, or this is just the first item, so the main item, we're giving it a lead key with an empty list, and we're simply appending the secondary item to it, and we are appending the main item to the main list, returning the item. So that's the abracadabra. And for the final part, this is when the spider has finished all its working, all its hair cutting, washing, and you know, the ordinary spider things. What else will a spider do? So we're giving it a random value in this range, and we are creating a file name, scrape data, which has random number it was given us from here. Next, we are creating a while loop. While this file name is inside of the pad, then we are giving it new values, assigning a new file name until it is not inside of the pad. So we're opening this file name, we give it an A+, open it as a file, and we'll simply writing to file JSON dumps self.json data, and we close it. Whew, that was a lot of explanation. So let's see. Yeah, we finished, and this is like the output. This is the main item: CPU, price, RAM, SSD, MacBook Pro, and the secondary item. So we have an output here. Whoa, that's a lot of outputs. Oh yeah, I did some testing. Which one is it now? Let's purify it. I wonder if it's this one. 1K searches. Well, it is a MacBook Pro. Oh, cool. I can delete this. I can delete this. Oh yeah, we found the right one. So, first one. We're looking for a MacBook Pro, for RAMs, blah blah blah, price. So we have a MacBook Pro. Based on the price, it's a very weak one. Then the second one, 1.5K. It's an i7. It has 16 gigabytes of RAM. Don't know about SSD. And the list goes on. This shouldn't be here. This shouldn't be here. That's weird. Okay, so these prices are okay. 3K. Well, this is something interesting. And this shouldn't be here actually. So, next one, MacBook Pro. i7 2.4K and the leads. So I actually don't want to go through this. I did actually some minor changes here. I'm gonna git init, git add, git commit, small fixes. Okay, that was it. Hope you liked it. If you liked it, like. If you enjoyed it, subscribe. I'm gonna be doing plenty of these kinds of videos in the future. Hope you liked it. Really do. I actually had to think hard. So, repay me by subscribing and enjoying this content. See you till next time.